Good afternoon, everyone. My name is Omotayo Rachel, a student from the Prestige School, Lagos State University, Faculty of Education, discipline, that's Science and Technology, Unit Physics Education. Yeah. So today on this video, I'm going to be talking about basic heat. Now, the contents we're going to be touching or talking about today is the heat, work, energy, temperature, how they're all related, and what about them? How are they related to heat? This kind of, you say heat, where does work comes in, where does energy comes in, where does normally temperature. When we're talking about heat, we're talking about temperature, but all of that. Maybe in my next video, we'll talk about thermal equilibrium, general law of thermodynamics, specific heat of solid, liquid, and gases. All of that we need to know. But for now, we'll stick with heat, work, energy, temperature. Now, I want to give a theory. Like when we're talking about this heat, what is this heat? Okay, first, two bodies are brought in contact, in thermal contact, changes their temperature until they are at same temperature. That's where thermal equilibrium comes in. I'll get there shortly. But first, when we're talking about this is, and it has to move from one body to another. Like it is kind of a movement you get until they are at thermal equilibrium, that is, they are at same temperature. Well, let's keep that aside. That's just a theory. Okay, so an instance. So what is this heat we're actually talking about? Okay, heat can be defined as a form of energy that flows from a hotter substance to a colder substance. I come again. Heat is a form of energy that flows from a hotter substance to a colder substance. Now, when we're talking about hotter substance and colder substance, we mean substance with a higher temperature and substance with a lower temperature. Now, I want you to make a key point. Is the it flows, like there is a movement. Yes, for thermal equilibrium to occur, or for we to say there is heat, there is a movement. There's a flow of temperature from one body to another. That's from the hotter substance to the colder one. Okay. Now, suppose we have a system and environment. Okay, when I say system and environment, okay, for instance, let's say a wooden block, okay, and a cool plate. Okay, when I say cool plate, that's the temperature of the plate is lower than that of the block. Let's say, for instance, the block is heated to about 35 degrees Celsius and the plate is just about 15 degrees Celsius. Now, when you place the block on the cool plate, theoretically, the temperature transfer will be from the wood to the plate. Now, the wood, it's a system placed, and that the plate is the environment. That's so the temperature of the wood, the system, the wood, let's say that's TS. Then the temperature of the environment, let's say that's TE. If the temperature of the system is greater than the temperature of the environment, it flows from the wood, that's the system, to the environment. Is that clear? If the temperature of the environment is greater than that of the system, that of the block, then the heat flow from the plate to the wood, that's from the environment to the system. That's a condition whereby both the system and the environment are at equal temperature. We call that thermal equilibrium. Now, well, since heat is a kind of a form of energy, like we stated earlier, that heat is a form of energy that transforms from a cooler substance, from a hotter substance to a cooler substance. It's a form of energy. Okay, so it's a form of energy. So we say, and the SI unit for energy is joule. So we can just safely say SI unit for it also is measured in joule. Another common unit that is used is calorie, and calorie can be defined as the capacity of heat required to raise 1 gram of water from, let's say, 45 degrees Celsius, 45.5 degrees Celsius to 55.5 degrees Celsius. Yes. So